right, this is APAB Calc. We're doing 2.3. We're going to touch on three big topics in this section: the product rule, the quotient rule, and higher order derivatives. So this video is going to specifically address the product rule. So the product rule is the way that you differentiate when you have two functions multiplied together. When you have a product that you cannot simplify. Now, when we do example 1 and P1, I've given you examples where you actually can simplify this product before you do the differentiating. I'm doing that on purpose so that you can see that in a situation like E1 or P1, you could either apply the product rule, because this is currently a product, or you could simplify algebraically and then differentiate using a simple power rule. So let's start by what the product rule is. So let's say that u and v are some functions of x. If y equals u times v, meaning a product, right, multiplication, then y prime is u dv plus v du, meaning u, the u function exactly as it is, times the derivative of the v function, plus the v function exactly as it is, times the derivative of the u function. Now, I'm going to go ahead and say right away that yet again this is another note card. Please, 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 please put one side as the derivative of with respect to x of uv, right, d dx with uv, and the other side is u dv plus v du. Please, 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 please. You're going to need the product rule. It's going to happen a lot. It's going to be on your AP. It's going to be required for much longer multi-step problems. You need to know the product rule. So let's walk through some practice now. Cool. So in example 1 and P1, I'm going to give you a problem that you could differentiate one of two ways, and we're going to do it both ways to just show you that either would work. Once we move past E1, P1, I'm going to start giving you problems that where the product cannot be simplified and you have to just deal with the product. So, so in this situation, I have a u and a v, right? I have two functions of x. X squared is a function of x, so is 5x to the 6th. They are being multiplied together. So if I do this using the product rule, method 1, right, my y prime is going to be u, which is x squared, right, u exactly as it is, dv. Well, the derivative of 5x to the 6th is going to be a 30x to the 5th, right? So u dv plus v, which is a 5x to the 6th, du, which is just going to be a 2x, right? The derivative of the x squared is a 2x. If I clean this up, right, this is going to be a 30x to the 7th. This is going to be a 10x to the 7th, right? So 30x to the 7th plus 10x to the 7th should give me a 40x to the 7th, right? So that's what I got when I differentiated using the product rule. Now my other option, right, option 2 was to, so my option 2 right here was to clean this up algebraically first and then differentiate. If I clean this up, this is just simple multiplication, so I get a 5x to the 8th. Well, now when I differentiate, I drop the 8 down in front to get a 40x to the 7th. And you'll notice it's the same answer. Again, I would not do, so to be 100% completely honest, I would not do the product rule for this problem, because if you can simplify a product, it's probably easier to simplify the product using algebra and then just differentiate. But again, after E1, P1, that's not going to be a choice. So we're going to do the same thing for P1 over here. Again, if you want to do it without me, you should pause me now. So option 1 is to go ahead and do my product rule. So my y prime would be u, which is x cubed. dv would end up being an 8x to the 1st, right? Plus v, which is 4x squared. Du will be a 3x squared, right? So my y prime ends up being an 8x to the 4th plus a 12x to the 4th, which is a 20x to the 4th, right? So if I do this using the product rule, I get a 20x to the 4th. If I do this using the other option, right, if I simplify first, my y is a 4x to the 5th, which means that my y prime would be a 20x to the 4th, which is, again, the same answer, right? Now, we're going to keep moving forward, and we're going to do more product rule problems that actually require that you use the product rule. So, again, in either of those two problems, I would not have actually used the product rule. And I can't imagine that any calculus teacher or anyone who regularly does calculus would have used the product rule. All right, let's keep moving forward. Let's do an E2. We're going to find y prime. So, let's do y equals x squared sine of x. Let's do y equals x cubed e to the x, because we did talk about learning that one, okay? And then we're going to do a P2 over here. Like E2, for A, we're going to do y equals, let's do 3x to the 4th cosine of x. And for B, let's do, x to the 5th times, let's do a tangent. Sure, okay, cool. So, we're going to go ahead and walk through these 4 product rule problems. So, again, here I'm in a situation where I cannot simplify this product. There's no way to clean up x squared times sine x. That's it. It's an x squared, it's a sine x, there's nothing I can do. So my u is x squared and my v is sine, right? So my y prime is going to be u dv, so the cosine of x, because it's the derivative of sine, so u dv, plus v, which is sine of x, du is going to be a 2x. Note that that 2x is not inside the sine of x. So chances are when you rewrite this, you're just going to clean it up and put the algebraic functions at the front of each of the trig functions to make it clear that the 2x is not inside the sine, okay? And that's really it. That's as nice as it gets. You can't do much more than that, okay? So same thing when I do b. My u is x cubed, my v is e to the x. So my y prime is going to be u dv. Well, the nice thing about e to the x is the derivative of e to the x is just e to the x. So u dv plus, sorry, over here I forgot to do the v du in case that helps, plus v du is going to be a 3x squared, right? So chances are you're going to write this with the algebraic stuff at the front, right? So you're probably going to make this x cubed e to the x plus 3x squared e to the x. And this one actually does factor, so this answer is totally fine. But there's a good chance that if you were looking at a multiple choice answer, this one would take out a GCF of the x squared e to the x and leave you with an x plus 3. Okay? Which would also be a totally acceptable x squared e to the x times an x plus 3. So if you want to pause me, go ahead. I'm going to walk through P2, and you should try P2 as well. All right? So here my u is the entire 3x to the 4th, and my v is a cosine of x. So my y prime is going to be u dv is going to be a negative sine of x, right, plus v, which is cosine of x. Du is going to be a 12x to the 3rd. Sorry, I sort of ran out of space. But so my y prime is going to be a negative 3x to the 4th sine of x plus a 12x cubed. That's a cubed. I just didn't write clearly. Cubed cosine of x. And that answer's totally fine. And I didn't mention up here, but you could have actually taken out a GCF of an x in that P1a. And just like here, if you wanted to factor it, you could take out a GCF of a 3x cubed, but I don't know that it's worth it, right? If we go to do b, my u is the x to the 5th, and my v is the tangent of x. So let me give myself a little bit of space. My y prime is going to be u. Derivative of tangent is secant squared of x, right? Plus v, which is tangent. Du is going to be a 5x to the 4th. So I'm going to get that my y prime is an x to the 5th secant squared of x plus a 5x to the 4th tangent of x. And again, you just want to make it clear that that 5x to the 4th is not inside the tangent, okay? So that's how we apply the product rule. Now, there are various ways to make the product rule more difficult, but that's sort of the gist of it, right? So that's essentially, well, I suppose we can do, let's do one more. Let's do an E3P3. Let's just make it slightly more to it. And then maybe I'll give you a challenge problem before we do the quotient. We'll see. All right, so for E3, again, we're going to differentiate. We'll find f prime. Okay, so I'm going to give you that f of x equals, let's do 3x sine of x plus 2 cosine of x, right? And then we'll do a P3, same thing. We'll do f of x equals, let's do 4x secant of x minus 2 tangent of x. Great, sure, okay. So let's walk through E3. So the trick here is that this guy is not a product. This is not a product, right? But this guy is a product, right? So this is a product. So what's going to happen here is I'm going to have to do the product rule for this chunk, right? So my f prime is going to be u dv, so u dv plus v du. And then, right, so that this whole piece is the product. And then this guy, I just go ahead and find the derivative because he's a separate non-product entity. So what's going to happen is I'm going to get that my f prime of x is a 3x cosine of x. And then these guys actually seem to be like terms, right? I've got a 3 sine x and a negative 2 sine x, so they just combine to be a single sine x. Now, if you want to pause me, you can totally pause me before I do P3, and you can try it on your own. And if you don't want to pause me, you can also just do it with me. So again, same situation here. This is a product, right? So I've got a u times a v, and this guy's not a product. I'm just going to have to differentiate him separately after I've done my product rule. So my f prime of x is going to be u dv, which is going to be secant tangent, right? The derivative of a secant is a secant tangent, right? Plus v, which is secant, du, which is going to be a 4, right? And then I'm going to have to differentiate this negative 2 tangent x, which would be negative 2 secant squared of x, okay? So it looks like I have, if I want, I can factor I have a GCF of secant, but really other than that, not much, oh, a 2 and a secant, not much else comes out. So I have a 4x secant x tangent x plus a 4 secant x minus a 2 secant squared of x. And that's really pretty ugly, but that's about it, right? So notice that sometimes I have things where part of the problem is a product, but the other part is simple differentiation, right? Cool. All right. So I'm going to give you a challenge problem for fun, right? So we won't even call it E4. We're just going to do a challenge problem. Okay. So, challenge. So the product rule only works if you have two functions. What if I gave you a problem like this? So we're going to find y prime. What if I gave you a problem like x squared e to the x sine x? Well, now I don't have a u and a v, right, which is super tricky, right? This is meant to be hard, by the way. If this comes off as daunting and if you're miserable after this, just skip this problem and go on to the quotient rule because you're going to be fine. This is intentionally meant to be super tricky. Here's the problem. The product rule relies on only having two functions. So you're going to have a product rule within your product rule. I'm going to go ahead and call these guys collectively u. But what that means is that du is another product. Right? There's a product within a product. How tricky, right? And I'm going to call this guy v. So my y prime, right, is going to be, so my y prime is going to be u, which is pretty straightforward, x squared e to the x, right? Okay, so u dv, which is just the derivative of sine, so that's cosine. Okay, that's fine. Plus v, which is also fine. And then du, and that's where this problem gets tricky, okay? So my du is going to be its own product rule. So let's do some work for that over here. I said, hey, my u was x squared e to the x. Well, that means that this has its own uv, right? So the derivative of this guy, my du, is going to be this u dv plus v du. So right here, I'm going to get an x squared e to the x plus an e to the x 2x. So what's going to end up happening if I clean this entire monstrosity up is that my y prime is going to be x squared e to the x cosine of x plus, now I distribute the sign, x squared e to the x sine of x plus 2x e to the x sine of x. Which is crazy and disgusting looking and not something you're probably going to have to do on an AP. But I just wanted to show you what happens if you had three functions as a product because you have to deal with a product rule as only u times v. So, super duper crazy, but there you have it, okay? Yeah, so this is the end of this video. We'll do quotient rule in the next one.